What would happen if an asteroid were to be heading towards the Earth? What would we do about it? How would we detect it? But most importantly, would we be able to stop it? Planetary defense and mitigation solutions. What do we do about it? What are the options on the table if we did detect a threatening asteroid? There's a lot of characterization that has to be done before you can work out what the correct strategy is to deflect it or minimize the damage. This goes back to something we've discussed over and over again, really, which is that the nature of the asteroid itself needs to be understood. So I suppose it's one of those threats and opportunities that people don't think about as much as, for example, other threats, climate change, and so on. Asteroids are rocky remnants left over from the early formation of our solar system about 4.6 billion years ago. These objects can range in size from a few meters in diameter to several hundred kilometers across. The total mass of all asteroids combined is less than that of our moon. Earth plows through to 300 tons of meteors a day. This is debris that is in the way as we move in our orbit. That sounds like a lot, by the way. This includes all the shooting stars you see at night. You add all those up, a couple of hundred tons a day as we orbit the sun, because we're moving 18 miles per second around us. That's fast. So we're doing a little sweeping up of our own. Ask how much total mass is there that we could sweep up, and compare that to the mass of Earth itself. If you do that, it is a mere pittance of our current total mass. There are approximately over 1 million known asteroids to date, according to NASA. About 26,000 passenger Earth, and over 2,000 of them are potentially dangerous near-Earth asteroids, of which 158 have a diameter more than 1 kilometer, making them 2.5 times as tall as the Empire State Building. We all know that a giant asteroid hitting Earth is not good news for life on the planet. While you shouldn't panic over an imminent threat for an asteroid, scientists have reason to be concerned about them. The created face of the moon is mute testimony to the frequency of asteroid strikes in the solar system. The June 1908 Tunguska event, in which a massive space object exploded over Siberia, released energy equivalent to 12 megatons of explosion and flattened an estimated 80 million trees over an area of 830 square miles. It is the largest impact event on Earth in recorded history, though much larger impacts have occurred in prehistoric times. According to the Lunar and Planetary Laboratory at the University of Arizona, our beloved planet has suffered up to 3 million impact craters larger than 1 kilometer in diameter, the largest stretching more than 300 kilometers in diameter. The Chicxulub impact event was a 100 million megaton blast that devastated the Gulf of Mexico region slightly more than 66 million years ago. This is also known as the cataclysm that killed the dinosaurs. We would not be here if that asteroid hadn't hit. The history of life on Earth would have been very different. Fortunately for us, dinosaurs didn't have a space program. See, we don't want the Earth to get hit with an asteroid. Say what you will about the ancient dinosaurs, but if they had a space program, it wasn't good enough. An asteroid came in and wiped them out. We don't want the same thing to happen here. Now you might think that asteroid deflection, asteroid detection is government work. It is. Every government in the world should be preparing for an incoming asteroid. Asteroid impact is something they should be concerned with. If we were talking about an asteroid impact, the way we talk about a lot of other things, we'd be getting ready. We provide grants to amateur astronomers who look for asteroids and track them. Yes, the old saying goes, it's like looking for a charcoal briquette in the dark. They're hard to find. And keep in mind that an amateur astronomer is quite different from an amateur sports player, an amateur tennis player. Amateur astronomers contribute a great deal to the science of astronomy, and they contribute a great deal when it comes to tracking these near-Earth objects. NASA and other space agencies have conducted a simulated exercise of an asteroid impact in which it turns out none of Earth's existing technologies could stop the asteroid from striking given the 6-month time frame of the simulation. This is why the goal is to find any possible impact years to decades in advance so that the asteroid could be deflected, defending life on Earth from asteroid impacts by deflecting them. But of course, asteroids are interesting for lots of reasons: science and resource exploitation, and just exploration in general in the future. So asteroids are very interesting objects, but what we learned when we looked at them from the planetary defense point of view was that obviously you have to know where they are before you can defend yourself against one that might be headed toward Earth. You have to be able to predict impacts ahead of time and to know that you got to find them. And one of the things that those of us working in the field realized was that with current technology, We're really close to the limit of our detectability of these objects, and at this point, we've really only detected about 1% of the total population that if it were to hit Earth, any of them to hit Earth could actually kill people on the ground, really do serious damage, so we really have to step up our discovery of asteroids if we're going to protect life on Earth from potential impacts. The most viable options today about asteroid deflection are kinetic impactor, gravitational tractor, and nuclear blast. Scientists have also suggested laser ablation, painting asteroids white, or even using the sun. However, among these proposals, the one that is currently being considered as more mature because it is based on existing and affordable spacecraft technology is the kinetic impactor, which charges the orbit of an asteroid by a direct hit of a spacecraft at a very high relative speed, several kilometers per second. NASA's double asteroid redirection test is a planetary defense-driven test of technologies for preventing an impact of Earth by a hazardous asteroid. DART will be the first demonstration of the kinetic impactor technique to change the motion of an asteroid in space. It is also the world's first full-scale mission to test technology for defending Earth against potential asteroid or comet hazard. It was launched on a Falcon 9 rocket from Space Launch Complex 4E at Vandenberg Air Force Base in California. As with all launchers, it required a sequence of precisely timed events to happen one after another. DART is the double asteroid redirection test. It's going to be the first mission to demonstrate asteroid deflection with kinetic impactor technology. So the spacecraft is going to impact the asteroid, and that's going to deflect it, sort of changing its position and its future path. This is the sort of technology that you would use if an asteroid was potentially on a collision course with the Earth, and you wanted to deflect it to keep that from happening. Now, the target for the DART mission is the Didymos asteroid system, named Didymos, and it's important to state up front that Didymos is not a threat to the Earth, so this is not a threat to the Earth. This asteroid is not on a collision course with the Earth. This is a good way to do this first test to demonstrate this technology. In September 2022, the spacecraft will smash into asteroid Dimorphos while traveling at a speed of around 6.6 kilometers per second. The impact is a test to see if this amorphous orbit can be shifted, as it is likely to alter the velocity of the asteroid by less than a millimeter per second. However, this will be measurable because Dimorphos is in orbit around the larger asteroid called Didymos currently. Dimorphos takes 11 hours and 55 minutes to complete in orbit around Didymos following the impact. Current estimates suggest that the period could decrease by around 10 minutes. This could be enough to avert disaster if a threatening asteroid were found early enough on a collision course with Earth. This asteroid system is a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future. While no known asteroid larger than 140 meters in size has a significant chance to hit Earth for the next 100 years, only about 40% of those asteroids have been found as of November 2021. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.